All right, let's jump right in and take a grand tour of our cosmic neighborhood. We're going to take a quick trip from the fiery heart of our solar system all the way out to its coldest, most mysterious edges. So you might want to buckle up.
So, what's with this number? Well, our solar system feels huge, right? But it's just one of over 500 known solar systems, and that's only in our own Milky Way galaxy. The actual number is probably in the billions. Kind of puts our little corner of the universe in perspective, doesn't it?
And if we zoom in, here's our specific cosmic address. We're in the Orion star cluster of the Milky Way. But here's what's really amazing. Our star, the Sun, is pretty special. It turns out only about 15% of stars out there are known to have any planets at all. So the fact that we even have a solar system makes us a bit of a rarity from the get-go.
So, we know where we are. But how did all of this get here? For that, we need to rewind the clock way back. About 4.5 billion years to be exact.
Okay, so picture this, a gigantic cloud of gas and dust just floating in space. Then something, maybe a nearby star exploding, gives it a gravitational nudge, and the whole thing starts to collapse in on itself. It formed this massive spinning disk called a solar nebula. Over millions of years, little bits of dust and gas in that disk started bumping into each other, sticking together, and growing. Most of it got pulled to the center to become the sun, and the leftovers, well, that became everything else. The planets, the moons, you name it. And right away, this process created two totally different types of planets. Think of it like a dividing line. Close to the super hot new sun, only heavy, rocky stuff could handle the heat. That's how we got the terrestrial planets. But farther out, past this frost line, it was cold enough for lighter gases and ices to clump together, and that's where the giant Jovian planets formed. It's a really key difference for our whole tour. So let's start our tour right there in the inner solar system with those four rocky worlds that call this hotter region home. First up is Mercury. It's the smallest planet and it's practically hugging the sun. This place is all about extremes. It gets absolutely scorched during its day and then plunges into freezing temperatures at night. And because it's so close, it just whips around the sun, finishing a whole year in what is for us just 88 days. Okay. Next stop, Venus. And wow, this place is basically a planetary oven. You'd think Mercury would be the hottest, but nope. Venus has this incredibly thick, toxic atmosphere that traps heat like a runaway greenhouse, making it the hottest planet by far. We're talking hot enough to melt lead on the surface. And after that furnace, we come home to an oasis, our planet, Earth. It's perfectly positioned in what we call the Goldilocks zone, not too hot, not too cold. And that perfect positioning allows for the most important thing for life as we know it, liquid water. It's the water that makes everything else possible here.
And that brings us to our last rocky neighbor, the red planet, Mars. And Mars, well, it makes you wonder, right? Could it have been like Earth once? Could it too have had life?
And the clues are pretty convincing. See, billions of years ago, Mars was probably a very different world. We found dried up riverbeds, deltas, evidence that suggests it had oceans, and a thicker, warmer atmosphere. But then, something happened. It lost its protective magnetic field, and over millions of years, the sun's radiation just stripped that atmosphere away, turning a potentially lush world into the cold, red desert we see today. All right, time to strap in again. We're leaving the rocky worlds, crossing the asteroid belt, and heading out into the realm of the giants. And the first one we meet is the absolute king, Jupiter. I mean, this thing is just massive. You could literally cram all the other planets inside of it. It's not solid, it's just this enormous swirling ball of gas, mostly hydrogen and helium. And you see those stripes? Those are colossal storms, including the Great Red Spot, a hurricane that's bigger than our entire planet and has been raging for centuries. Next up, we've got what has to be the jewel of the solar system, Saturn. It's famous, of course, for those incredible rings made of ice and rock. And get this, for scale, the rings are so wide, you could fit them in the space between the Earth and the Moon. But for all that size, they are razor thin. In most places, they're only about 30 feet thick. Just incredible.
Heading further out, we meet our first ice giant, Uranus. It's different from Jupiter and Saturn. Its atmosphere has methane, which gives it that pale blue-green color. But the craziest thing about Uranus, it's been knocked over. A long time ago, something huge must have slammed into it, because today it essentially rolls through space on its side as it orbits the sun.
And here we are at our final planet on the tour, the other deep blue ice giant, Neptune. Being the farthest out, it's a dark, cold world. And it is incredibly violent, with the fastest winds in the solar system whipping around it. It's so far out there that astronomers actually discovered it using math before anyone ever saw it through a telescope. So we've seen all the planets, but hold on. The tour isn't over yet, because beyond the planets, there are these huge fields of cosmic leftovers that tell us a lot about how this all started. First up is the one between Mars and Jupiter, the asteroid belt. You can think of this as the cosmic rubble from a planet that never quite got built. The massive gravity of Jupiter, its neighbor, kept all these rocks from ever clumping together. And the objects in there range from tiny bits of dust all the way up to a dwarf planet named Ceres.
So you have that asteroid belt, right? Well, it has a way bigger, much icier cousin lurking out in the dark called the Kuiper belt. This one orbits way out past Neptune. And where the asteroid belt is rocky, the Kuiper belt is a frozen wasteland of icy debris. It's the home of dwarf planets like Pluto, and it's the place where a lot of comets get their start.
Okay, one last jump. We're going to the very, very edge of our system now, to the boundary where the sun's influence finally starts to fade. This is a place called the Oort cloud. Now, we haven't actually seen it, but scientists are pretty sure it's out there. It's this giant spherical bubble of icy objects that surrounds everything we've just seen. This is what we consider the true edge of the solar system, where the sun's gravity finally gives way to the vastness of interstellar space. And that really brings our grand tour full circle. When you think about it, from the fiery sun at the center, through all the different planets, to the icy debris at the very edge, it's this whole specific, particular setup that makes our solar system a pretty special place to call home. And that kind of leaves you with this one big question, doesn't it? Out of the hundreds, maybe billions of other solar systems out there, what is it about this one? What makes our particular lineup of planets so uniquely special that it allowed a world like ours to exist in the first place?